electronics. Partially stolen from Team 987's presentation. Yeah.
The best, right?
Can you tell us about what electricity is?
So what is electricity? At its core, it's the passage of electronics through a conductive material like copper due to copper's atomic structure. Voltage is similar to pressure in a water system, and the more voltage that you have in the system, the faster the charged electrons will move through the loop. Amps is a unit of electricity that we use that measures the amount of electrons in the circuit or the strength of the electricity. The more amps you have, the stronger the current.
R2 ohms is the measure of resistance in a circuit. The more resistance, less amperage there is. So you can kind of think of it like a pipe. So like if you have low resistance, then it's just like all electrons flowing through without much stopping it. With high resistance, it more brings it to, you think of like a trickle of water, but with water being electron.
Watts. Watts are a number unit of energy that we use. It's the rate that energy is consumed within the loop. So looking at our pipe.
Oh yeah, that's the wrong image.
Oh, okay.
So watts is like amperage combined with times voltage is how you get watts, and so you just kind of measure like overall power draw of something. You can only see it in like computer power supplies and
Yeah.
like this stuff. So yeah, just like kind of gives you a general like feel of how much power something's drawing.
So generally, when you're talking about the flow of electricity, are you talking volts, wattage, or I mean, is it
Kind of a combination, because something can be high voltage but low amperage, or something can be like high amperage, low voltage. So watts just kind of gives you a general like feel of like how much something's drawing in total.
And how much voltage are we going to be using? How many?
So our robot uses 12 volts and 5 volts. 5 volts for like the brains of the robot, the robo reel, and 12 volts for all the other systems.
12 and 5 volts. 12
Yeah,
and 5.
and the 12 volt electronics are the ones that are not as regulated. Those are like our motors and things like that, where we're just taking the power straight from the battery. Whereas our 5 volt ones, and there are actually some of the 12 volt ones that are regulated, but for the most part, we're going to be dealing with our 5 volts, and that's our brain, and that runs on a power regulator, which makes sure that the power isn't all fluctuating, because it will use a lot of power draw when we're having a robot in motion. And like, for example, the network switch or the router, we don't want that to randomly lose power in the middle of the match, because it's getting power drawn from the motors. So that's why we have that voltage regulator module.
Yeah, because like you can do some pretty large jumps like when it's drawing from the motors. Like it's been between like 10 and like 14 volts for like jumps around for but the motors aren't that picky. So they don't really need as regulated, so it's more directly connected to the battery. So this is a useful circuit. So in this, R is for ohms, resistance. E is for wattage, and I is for voltage. So you can cover different components of the circle, and then you can find the equation. So if you cover this, you'll see that the equation you get, I forgot what I is, it's on the next slide, is E over R. So you can kind of use it as a quick guide to find different useful electronics equations.
Okay, so when we add a component, are we going to have to do any calculations or anything?
Not that much, just to kind of just need to verify like voltages for different systems before connecting the power, so we don't fry anything. But we shouldn't have to do too much actual equation. Here's a more fancy version of that. So we won't be using this too much, but it just kind of shows you all the different power equations which we use in like engineering electronics. But we shouldn't need to use this too much. If we do, then I'll tell you how to use it.
visuals help.
I don't think the robot's in shot. Coming.
Here, I'll stay on this
No, I
side.
know the robot's not in shot. Getting us ready.
Ready for the next slide?
Yeah, we can do the next one.
So why are electronics important? Well, this would not do anything without electronics. If electrical on a robot isn't done properly, then this can either cause things on a robot to break or not work at all. So for example, CAN wire, which is this green and yellow wire right here, works as a daisy chain. You can kind of, I don't know if you can see it from back here, I can pull it around so I can show everyone more clearly. But this wire right here, it works like a daisy chain. So it goes between each part that needs it to supply power and data to it. And what's really cool about it is how it works is it'll send out a signal and it'll go like, okay, this is in a series, this is in a series, this is in a series, this is in a series. And then when you're programming it, you can say like, okay, send that code to object free, and it'll know what's number free in that loop every time.
As opposed to the other method, which is like PWM, where each device is directly connected to the RoboRio, and then it just sends the signal to that channel instead of having to go through like a bunch of things which I might not need to use before sending it to a component which needs to get the signal.
Which are these white, black, and red wires right here. We use them actually for some of our motors, not all of them. Mainly our, I believe this one up there is PWM. Our solenoids, I believe, are PWM.
I think all the motors currently are using PWM.
Yeah.
Because it's also a lot easier to code because you have to like determine where the loop is, and if the loop breaks, then
The whole thing breaks.
everything past that point and the CAN will break as well. So PWM just seems to work a lot better. But they are more expensive motor controllers, which is why our first year we didn't have them, but
So the RoboRio, that's the brain, what's equivalent to the
Yes.
brain and Dex? Is that right? With the
That
brain
is
and Dex?
this computer. Oh, I can actually pull it off because I velcroed it. This is the RoboRio. This takes all of the programming that is sent over this little radio right here, which we connect to.
RoboRio going around.
Oh, cool. But it connects through Wi-Fi Direct actually, and sends commands to our RoboRio, which processes them and sends it out to the correct device. Now, from an electronics standpoint, here is another part of the brains, which is our, I think we've velcroed everything. This is our voltage regulator. No, that's actually our voltage regulator. This is our power distribution panel, sorry. It takes all of our current from our battery and kind of like splits it off into junctions that everything can use. Now, for the more controlled power, that's our voltage regulator module, this little thing right here. And it basically was, like I was saying, how it's getting that unstable, like very crazy power coming in from a battery, which usually sits right here, because these motors draw a lot of power. So this cleans up that power so that way it has a consistent flow of nice DC power that things like the radio can utilize, the motor controllers can utilize, the hub can utilize, because otherwise then they'll shut off, and that's really bad during competition if you lose connection to the radio.
And so is the Wi-Fi pretty reliable? Is that the most reliable thing?
I think we've only had a drop off like once or twice, and that was just because of distance. Like we went, I think it was when we were driving it through the halls that one time.
Okay. During competition, we never had a problem?
No, we were fine.
because
Okay.
you can't use Wi-Fi at competitions, so they keep it for just the team, so there's not any issues.
Oh, so people in the stands can't use the Wi-Fi?
Well, say some of them do, but technically they're not supposed to.
Okay.
The one thing we did find out though, which helped our connection a lot better, when you put it in here in the center, this metal all around here, it's basically creating a Faraday cage, which we found out last year. So you want to have your router mounted up pretty high actually, so that way you can get a signal up and out to your computer. Next slide.
Questions?
Got some questions?
It runs off of Wi-Fi, or it doesn't use radio signals to control it?
Wi-Fi actually.
Yeah, it is.
Sean, you want the spec?
It says, oh, it actually has a
No,
little
we'll
router
just keep
on
pulling it back and forth so that way they can keep
On the router, is that a picture of Wi-Fi?
Huh?
Is that Jamma on the router?
This is fine.
It's the Phil Swift.
Yeah, Phil Swift
Phil
sponsors
Swift Art
FRC.
Department.
Do all the teams use Wi-Fi? Is that how it's works?
Yeah.
Yes.
Okay.
That's why we're not supposed to have our phones on
Okay.
Wi-Fi or hotspots or anything like that during the competition.
So there's two main types of metals and wire: copper and aluminum. So aluminum's more like made of a bunch of small strands, and copper's usually like thicker and stiffer, but more durable. A lot of the wires on our robot is aluminum because this tends to be easier to wire manage and they're cheaper. But there's some copper wire, like the ones coming directly from the battery into the robot, as that's low gauge, which means thicker wire.
Yeah, American Wire
You'll
gauge
see that on
is
the next
annoying.
slide.
Next slide.
I think that's the wire gauge one. Nope.
Nope. So PWM wire, as we demonstrated, I'm pulling it out. It won't be on camera if I don't.
Yeah.
So PWM wire, this wire right here, as we were talking about earlier, it directly sends it through the hub to each individual device instead of like our CAN wire here where it's all in a loop. Next slide.
Does anybody have any questions about what they're going on along? Don't hesitate to ask.
Yeah.
If you need them to repeat anything, right? So.
And I believe all these will be uploaded to the resources page of Discord so that if any of you guys need to refer back to these for any reason, they'll be there. And as well as the YouTube channel.
Who's going to do that?
I'll take care of it.
Okay, good.
Okay, you could probably skip this one too, but
Skip it.
CAN, daisy chain. PWM, not daisy chain, it's direct.
And I think Dylan drew a diagram the first time, but like daisy chain is fun because it's kind of like we draw like a daisy where it's like all like loop like that.
Yeah.
Whereas PWM directly goes into like the robo reel. It's like that. They're all like separate ones. Just so you can.
It's not about drawing.
And that's the CAN bus is all the wires coming to one structure.
And yeah, both of them work digitally too. Or no, is the first. Is PWM analog?
Phosphorus ones.
Oh. I don't know.
Those, like those.
Wires!
These are the thick wires.
Yeah. Those go straight as the battery, right?
Yeah.
So, as always with electricity, there are two different types of power that we're going to be using. AC,
We don't
alternate
use
current.
AC though. That's like what using the wall, but
Yeah.
we don't use it on this robot.
We don't use it on the robot. And
You can.
DC. I mean, you can, but
That
know,
batteries
there's so much
usually,
power from
the
it.
batteries are DC, right?
yes, the battery is DC.
I think it's an electric scooter battery actually.
Yeah. Hey.
We won't be using alternating. Do we ever use alternating current for anything?
No.
So this nightmare. Do you want to explain American wire gauge?
So-
Because I hate it.
American wire gauge, it kind of works opposite way, I think. So the higher the number, the smaller the wire. So like a 26 gauge wire would be like that, like 18 gauge is this. And then, so most of the time we use 12 to 14 gauge because it meets the requirements for the amperage that we use for most systems, and it's like easier to navigate. But like the thick wire coming from the battery, that's like, I don't know, that's a lot
Like
lower gauge.
6 gauge, 8 gauge.
Yeah.
So the higher the gauge, the smaller the wire?
Yes.
It's the reverse of what you think.
Annoying. So soldering irons. You will be doing not a lot of soldering, but you will be doing quite a bit of soldering because wires break. And we gotta find a way to fix them without just restringing the entire wire.
So it doesn't really matter which method you use to solder as long as they're making connection and So you can, some people like to twist it, some like to twist like that or like that, but as long as the solder is making a strong connection and if you tug on it, it doesn't come loose, that's good solder. But also towards the end of last season, we started using jelly beans, which are like, well, that's what Dylan calls them. I don't know what they're actually called, but like these small things, and then you like put a wire in, put another wire in, and then like screw it in, and then it's kind of
tanks.
Yeah, but
Like little
they look like
caps, yeah.
square version of that kind of. But yeah, so those are more like simpler for like less permanent connections, and they work well.
So in the competition, we might have to use those instead of soldering, obviously.
Or another
Like,
option.
here's some of them too. They're kind of small, but
Another
yeah.
option too, which I accidentally said instead of, I thought you were talking about something else, but do we actually have any crepe wires? We don't have any crepe wires.
Yeah.
No, we do. So wire crimping is another, I don't know if you can see these, but it's where you take the wire and you kind of like smash it between a piece of plastic and smash it between another piece of plastic, and it also conjoins the two together because in that piece of plastic in the middle, there's metal lining it, so it can conduct. But that's just a few of the ways that you can connect wires together is soldering, crimping, and LEDs.
Guys, keep that in mind. You'll be doing some soldering. We'll all be doing some soldering.
And for those that are interested too, if we have any time left over, we can do a soldering demonstration.
Oh man.
Don't burn down.
Please don't.
Necklace.
Yeah, we have a bunch of them. So heat shrink. So once you solder, you'll have exposed wire, and that's not good to have just randomly around because
Especially on a metal
fire.
robot.
Yeah. So we usually put heat shrink around it, which is just like a rubber material, and then you use like a source like heat gun. A heat gun is what it's called. It's like a hair dryer, but spicier. And then it mounts the plastic around the metal, so there's no exposed wire and nothing shorts out. Yeah.
So we use iron as the conductive material for soldering.
The material we use for solder, it's called solder. It's like part lead, part tin.
Yeah,
some
so
toxic lead fumes will be in the air, but no, it's not that.
try to not breathe in too much. Like,
That's why it needs to be like well ventilated, but it's safe.
yeah, it's a good idea.
Breathe, they'll vaporize metal.
Yeah.
Where is our heat gun?
Somewhere.
Somewhere.
So yeah, this is the thing I was talking about, the heat gun, and that's the tool, which is like a hair dryer, but a lot warmer. That you use to heat up the heat shrink. So you can see we have heat shrink kind of like everywhere on connectors or electrical wires. So it's keep all exposed wires out of the way. Excellent.
So wire cutters. Every once in a while, you'll need to yank out a wire, and to do that, you're going to have to cut it. So there's three main types of wire cutters, including, I guess you can use, those are pliers. I guess you can use pliers and a pinch, but mainly you'll use your flush cutters, which are the ones that they're flush, so they cut flat, and they'll be used for cutting 12 gauge, which is like probably this wire, that wire, like the smaller wires. Those are all 12 gauge. And then your diagonal wire cutters are those big, like chunky, like they'll probably cut to bone, I believe.
No, not those.
No, or those ones that can cut to bone.
None of these. The ones in. Those are like the semi.
Oh, the pneumatic ones. That's
Yeah, the pneumatic ones.
Somehow.
Yeah, if you cover a pneumatic one, that'll cut off like your fingers, so be careful of those in the back.
You don't have one of those things like that.
Printer right now.
And we have electric wire cutters.
Okay.
No, we do not.
So anytime you do any type of soldering or anytime there's a connection, you gotta cover the wire, right? You can't have any exposed wire at all.
Correct.
None of that. Otherwise it would probably start a fire.
Because we actually, I believe we had a problem last year where the robot was grounded to something. And it
Okay.
was starting to, I don't know if it shorted out things, but we almost failed an inspection because of it, because
Interesting, yeah.
it was passing current through the body of the robot, if you all notice, is
Okay.
metal.
Giant
So that-
taser.
And
So
if,
that's-
yeah, giant taser. If-
That's one thing you gotta always check, make sure all your wire is covered.
Absolutely.
Even if it's with electrical stuff, right?
Because another thing that could happen too, it could, if it's not covered properly, it could arc to another nearby wire and short out components of the robot.
Yes. Yep.
I did that when I was installing speakers on the car, and
And there's been teams before where the robots like exploded because of that. We should probably find one of this video. So, oh yeah, here's the big things. Yeah. So Crimpers is what we were talking about earlier. So that's where you have like a thing which is plastic with metal in the center. They just use a lot of force and then there's like squeeze the wire in between the two ends of it. So it's like an alternative to soldering. It just uses like force to hold it in place. But yeah, like those are dangerous. You put your finger in it. So, but they can also be useful if you don't want to solder for connecting things.
So, pins and lugs, these are the things that you crimp on the end of a wire. So, our battery connectors, those had to be put on our wire somehow. And to do that, we use pins and lugs. Pins, they go inside of the connector, which is that little plastic thing right there. And when you use the smaller pins for the CAN wire, you want to solder the end, just so that way it won't fall out when you crimp it. Because otherwise then it'll like, I don't know how to describe it. It like looks like hair, how the wire falls apart.
Oh, frays.
When you, yeah, it frays when you crimp it without soldering it, especially the CAN wire.
And then those we just screw into the battery terminal. Yeah, because it's a big giant metal piece.
Yeah.
You guys feel comfortable doing that? I mean, could you do that? That's something we could do.
If we have any lying around.
Yeah.
So, black is hot.
Black is usually negative or neutral or ground. Yeah, it depends. And then red is usually always your positive, your current coming.
So red is.
Yeah, you don't want to mix them up.
Yeah, that
I think we'll be okay.
usually creates some fun sparks if you touch the two.
So we use multimeters to find a lot of things. So find the voltage of things, test like the amperage of different things. But you can also, useful things is you can connect it to two ends of circuit that you think is hooked up, and then it has continuity mode, which will beep if the signal is flowing all the way through it. So you can use that to detect breaks if things aren't working.
Or if something's grounded that shouldn't be grounded, because we were hearing beeps on the edge of the robot, and that should not be. I don't even remember what it was that we were connected to. Was it the lights?
It was the RGB lights.
It was, yeah.
That were shorting to the.
We make use of fuses.
Yes, actually. We have fuses all on our PDP. These are all 40 amp fuses.
You don't need to
Needs to get it. I'll put it back in later. I'm gonna pass this around, but this is a 40 amp fuse, and if that pops, we definitely did something wrong.
Yeah, it shouldn't get to 40 amps. It's like you plug your robot into the wall or something.
We do have the little tiny ones. We have a 20 amp fuse and a 10 amp fuse right here at the front. These little, like, you can barely see it, but you can see them sticking up right here. And this will blow, and then when these blow, that's when things are really bad. That's when you should probably turn off the robot because it's about to catch on fire. Next slide.
Here's a very simple diagram.
Yeah,
Yeah, so here's the diagram. What'd you say?
Is that?
Oh, I thought you said something.
Yeah, that's a good diagram.
Yeah, so this kind of looks a little overwhelming at first, but it kind of has the wiring for like pretty much anything on the robot and like the path that it goes. So you kind of like it's really been very helpful for our team to like follow where different things go. I think I guess this game did it 3128, and yeah, it's a good like guide for when you like forget where things go and to just kind of wire the robot up.
So guys, make sure you're familiar with this, right? Because when you're working on it, you know where it's connected.
No,
like correct this one. Alright, next. Battery.
So, battery. I'm going to go grab one just to show
So it's actually a motorized scooter battery that we use. And it's 12 full 18 amp hours. So I don't really fully understand what how amp hours. So amp hours differ from amps, but I think it's something else. I'm sure how. But yeah, so that's the rating of the battery. And they're lead acid batteries, so you don't want them to spill because they have lead and acid in them. But they're these big heavy batteries, so you can pass it around if you want. This is the one. This one died.
Can we put a full car battery in one of those to make it go fast?
I don't know. Yeah, probably
What
not.
are they compatible with?
If we stick like a gasoline engine on it, make the robot go faster.
I think some teams use lithium batteries though also.
Yeah.
They're more expensive, so we just use the lead acid batteries. Alright, next slide.
So it's likely to be using the same components.
Yeah, we have like
Yeah, the
7
batteries
of
are
those.
standardized.
And they keep sitting here. Oh yeah, so it go boom if you connected wrong, so try not to do that. You should always check your connection to the battery to make sure that the terminals are fully covered, so it doesn't short out and do that, which isn't good. Yeah.
I'm sorry, did that battery like catch fire?
Yeah,
that's-
caught fire and leaked acid and not good.
They didn't cut the right wire.
I think the terminal was exposed on it and then it shorted out and then, yeah, it can cause issues.
Especially because these batteries are 18 amp batteries. That's a lot of power.
They're actually 18 amp hours.
Amp hours.
I need to figure out like what that means because it's different from. All right, next slide.
But either way, they're not small batteries, and we're throwing around a lot of power here. So
So here's the big breaker, which we use as the on switch. It's like rated for what's it rated?
120 amps.
Yeah, it's rated for 120 amps, so it shouldn't pop, but we mainly just use that as like the on switch to when you plug in the battery to turn on the robot.
So if this is in the off position, no power is being generated.
Yeah,
Correct. It is literally opening a bridge.
I just screwed on the robot. It's right here. Oh, it's right here.
So when you flip it, on the robot, where's the battery?
That's the dead battery.
That's the dead battery. When was the last time we charged any of the other ones?
One of them is probably just
Magic cheap.
So when you press this in, this switch right here, it bridges the connection and connects this red to this red. And then when you press it, it opens the connection so nothing can flow through.
That gas cylinder that's put in the back, right?
Yes, this is an air cylinder actually. It fills completely with air and then we're able to dispense it at our needs. These pistons right here last year we used it to lift up the robot.
Is there a reason we don't use hydraulics?
They haven't specifically stated it, but I can assume it's probably because. No, I know it's illegal, but why do we not use it? I'm guessing
Because
probably
there's a
just
leak.
leave it.
Oh,
Yeah, there's a
That's why
chance
we
that
have it. Like, there's a running joke in the FRC community of, oh, first needs to give us a water game 1 year. And yeah, that's probably the same reason why, because robots and water don't mix too well.
Oh, yes. I think it's a max of 60 psi for the battery.
So trash can and water.
Power distribution. Okay, so we were kind of talking about that earlier, but here's a diagram of it. So that's where the power from the batteries feeds into, and then it distributes it to the various systems and regulates them to various degrees. So they all have breakers, so that those trip hopefully before there's a fire. And yeah, the 12 and 14 gauge wire comes out of that. So things you can connect to this. You can connect motor controllers. Yeah. Pretty much anything that needs power will go through the power distribution panel. So like, yeah, everything in the robot will come from there to the different channels depending on how much power it needs.
And from PDP specifically, there's a fun little way of how to get wires into here. So you have to shove a screwdriver into here and pull it up while another person like pushes into the wire into a little hole that has a little metal connector that will grip it. I could probably show them that later too with the screwdriver wherever that's going.
Which I've never done. I wrote for one time.
We can talk about
So the Robo Reno, we kind of briefly covered.
Mind if I pass this out? So this is an opened up power distribution board. It doesn't usually look like this. It has a plastic covering over it. You guys good? Check it out. Pass it around.
So the Robo Rio we briefly covered earlier, it's basically the brains or the computer that takes all the instructions that we send via the programming through this radio here, and it interprets it and sends it to proper devices. It can also drive any computer vision that we have up here and any webcams, so that way we can control them and interface them directly as if it were directly from the computer.
So the things that connect directly to your Robo Reel is the RSL light, which that is always blinking whenever your robot's initialized or solid. It's like one of the two indicates that your robot's on and it can move at any time to let everyone know. And also the radio, which is just a little router which communicates with the laptop. Then Limelight, whenever we get ours, that's the vision system camera that team member on Simran created, which helps automatically track balls and like shoot them into the baskets. And they created a whole like API for it and stuff. So it's a lot of teams use that to like kind of auto aim.
Yeah, pretty much. It's like aimbot for robots.
And when that operates as part of the program, you can have.
Yeah, they kind of like shoots. That's basically it is. It's like aimbot.
Just make it entirely it's not automated, it's coded. Because, but if you make artificial intelligence for it, just make it go to
So the VRM helps regulate like more like system electronics, the voltage for like the lower like 500 milliamps to 2 amps circuits. So unlike the other voltage module, this one like is a lot more precise in the voltage. It keeps it in a very like tight range.
Oh man, 40 cables. Someone still has the fuse out, so we kind of can't do that either. Oh, there's the fuse. I'll plug the fuse back in. So, pneumatics control module. This isn't really as much of electronics as it is programming and stuff, but there are electronics parts to it as well. It's kind of like our VRM over here, in that it safely takes our higher unstable voltage and safely delivers power to our pneumatics, especially with our solenoids, which are simpler. Where's the solenoids?
Maybe they were taken off.
They weren't taken off, they're still on here. Where's the where? Oh, our solenoids, which direct airflow to our pistons right here.
So do all the teams have pneumatics? They all use them or no?
No, not all teams have pneumatics, and if you find another way to accomplish the task without pneumatics, then kudos to you. It's kind of just another thing that we have at our disposal to use for various things.
What do some of the others use instead?
Well, we used it last year to lift our robot. A team could probably use it on the flip side to lift up their robot if they need to, or they can use it to push something or hold something. Like there's so many uses for pneumatics.
Okay. So the plan is to use it again this year, use it again this year?
Definitely.
Merry Christmas.
We're back with a remote kill switch.
Yeah.
Yes, actually, in the program there is a big stop button in the software to stop any code going to it, as well as to stop it. On the robot, you just open the breaker.
So there's different types of motors and motor controllers in FRC. So there's brush motors and brushless motors. So brushless motors are lighter, smaller, faster, longer lifespans, but they wear eventually. Brush motors are reliable, but for high intensity uses and have a lower lifespan, higher maintenance, and heavier and motor. And then, so we're using for the motor controller the Sport Max because they're like the fancier ones that tend to work much better. But before we used the CAN Rev, the CAN next one.
Here somewhere.
Yeah.
Next one. Yeah, this thing which uses CAN.
I believe we're using brushless motors for all of ours now.
Yes. Next slide, Thomas.
This year is
So here's just some of the different types of motor controllers as well as motors, which we have Neo motors. We have 4 of them, 2 for each side, and they can go double speed with running both of them, single speed running one of them, forwards and backwards, and can be used to turn by applying half power to each side respectively. And then we also have our
That's obsolete
one
now.
of well, I think
No, we have the Victor SPX because the Talon they
that's
go
the
Victor.
Victor. Okay, so this is also like that.
So each motor has a motor controller?
Yes. Which that's what you program actually. You program the motor controller, which then tells the motor, hey, run.
This way you can customize it, one would run, the other one wouldn't.
Yeah. Here's the more modern ones.
Yeah, these are the things we're using: the Spark Max motor controller and the Neo motors, because they're a lot easier to code, more reliable, and run better.
And they're
They
way quicker.
They go extremely quick. Like we have to limit it a ton so it doesn't like run to the wall whenever you hit it.